Hello, everyone. Welcome to Theo-MathProblemSolver. In this particular episode, I'm so excited to take you through the journey of integration by part. In our previous episode, we look at integration by substitution, and we kind of look at some of the techniques we can employ in order for us to use that to solve problems. Okay, but in this particular episode, sometimes, you know, we may not really have success in using integration by substitution. So we have to rely on another powerful method of integration, which it is known as integration by part. So stay with me even as we do that together. And at this point, if you have not subscribed, please do so. Turn on your notification button so that anytime I release new content, you will be the first to receive that. So stay blessed. Let's get going. So we are looking at integration by part. So what integration by part, one thing that I want us to sort of note is that we kind of leverage the reverse of the product rule in differentiation. If you could remember in previous episode, we kind of talk about certain things that needs to be done in order for us to use a method. But in this particular instance, we are using the tool, one of the tools that we learned in, or one of the techniques that we learned in some of our previous episode. We said that with a product rule, suppose we have two functions. So let me lay the foundation again. Suppose we have two functions which are functions of x. Let's say, suppose we have u and v as two products, okay, as two functions. And so anytime, what happens that anytime we kind of find their product, remember u and v are functions of x, okay? So suppose we kind of take their product. Anytime we take their product and we find their differential, we remember that we said that we'll get something beautiful as this. All of this we learned in our previous episode, and I would want you to, just in case you want to revisit that, you may want to do that so that you have a better understanding of what about we're about to do. Now, how do we come about the integration by part? As I mentioned, we kind of leverage the reverse of the product rule in differentiation. Okay, so we're going to use this technique, or you're going to use this as a stepping stone to derive the formula for the integration by part. Okay, so at this point, what I do is that what I'll do is I will take the integral on both sides. Okay, I'll just take the integral on both sides at this point. Then what then happens is that we'll just cancel the dx. Then when that happens, we're going to have the integral. We're going to have such result, okay? Then plus the integral of v du, okay? Now, what then happen is that we are going to ask ourselves one or two, what's the integral of this? What's the integral of this? So over here, you see that the integrand over here is 1. So when you find the integral of that, you're going to have what? So the integral of this will just give us what uv, okay? And what does so what happens is we are going to maintain this and that as well. Okay, very good. Now, what we need to do is we are going to isolate, we are going to isolate this. And by isolating that, what it means is they're going to have u dv equal to uv minus the integral of v du. Okay, so this is now we're going to have this as our integration by part formula. Okay, so now we've been able to derive our integration by part formula. Okay, and at this point, if you have not subscribed, please do so. Like our content, and comment and help share this powerful content to your colleagues and loved ones as well. The whole point of this platform is to create a community that are not math phobias. I mean, some of the view that mathematics cannot be learned, math is difficult, and it's only for the geniuses. But I must admit that mathematics can be learned, and with a powerful content and with a powerful platforms, you should be able to understand it. So let's help create that community. All right. So let's get going. So now that I have this formula, what are the tricks? What are the techniques, involves in deploying such such formula? Okay. So for us to do this, what happened is that we want to ask ourselves one or two questions. Now, what happened is that our U should be such that our U so our choice of U should be such that it is easily differentiable. Okay. Our choice of U should be such that it is differentiable. Is that okay? So for us to choose a function to be U, that function must be differentiable. So important that that function should be differentiable. And then I also want to sort of point out that the dv should be easily integrable. Okay. Our dv should be easily integrable. Okay. So our db easily should be easily integrable. Okay. Very important. Let's take note of that. So one thing I mentioned that U has to be, differentiable, and our dv should be easily, integrable. So let's take note of this. These things, they are so important. So I'll take my time to make sure that each and everyone understand, the basis, so that anytime I bring you in any question that is quite complex, you would just have to rely on the foundation. I think you will be fine. I hope that is okay. Now, there's a common, heuristic for kind of solving integration by part problems. Okay. And what is that heuristic? So the heuristic is what we call the latte. Okay. The heuristic is what we call the latte. It's a technique, or is some sort of shortcut way of solving integration by part problems. Okay. All right. Okay. So we call it the latte. The heuristic, we call it the latte. The latte. So the L stand for logarithmic. Okay. So let me take my time to write down. The L stand for logarithmic. Okay. Logarithmic functions. The I stand for inverse trigonometric functions. Okay. A stand for the arithmetic. Okay. A stand for the arithmetic expressions like polynomials. Okay. Like polynomials, any polynomial you have. Okay. So inverse tricks will be like maybe the sine inverse, okay, of x, cosine inverse of x, the tan inverse of x. All of these things, when we see them, you want to kind of take our time to. And then the logarithmic functions, as we may know, we have the ln x, the log x, and all of that. Okay. All of these things we want to use such things. And then the T, what is the T? The T stands for trig functions. Okay. So T stands for trig functions. And as we may know, we have the sine x, the cosine x, the tan x, and all of that. Okay. And then finally we have the exponential functions. Okay. So when you have the exponential functions, so exponential, you have be e to the power x, e to the power 2x, and all of that, okay? Or maybe um 2 to the power x, all of these things, these are exponential functions. So for the choice of u, let me kind of point out here that the choice of u will rely on what we call the latte. The latte is a heuristic for sort of making our work so simple to sort of make a choice for u. Okay. So these are, I would want to point out that the L has higher orders compared to the inverse trig functions, and then the inverse trig function has a higher order as compared to the arithmetic expressions, and so on and so forth. So I would want us to kind of follow that. So anytime I give you a problem, you have to, and you want to make a choice for you have to make sure that which of these is coming first. So if I give you an integral problem and in the integrand you want to sort out for u, what happens is that you have to now rely on this, okay, to solve that. Okay. So what happens, I'm going to give an example and we are going to kind of use that so that you understand what I'm trying to say. Is that okay? Very, very important. Let's take note of that. So important. All right. So let me give you a very, simple example for us to set the ball rolling. Let's go. So the first example. So if I ask you to evaluate, so evaluate. So if I ask you to evaluate the lane x, okay? So I have you to evaluate lane x, okay? The integral of lane x. How do we do that? How do you solve this integral problem? You see? How do we sort of solve this? How do we do that? All right. Now, remember that with this problem, what I would do is that if I were you, what I would do is that I'll write my latte, okay? I'll write my latte down, that ask myself one or two questions. That you remember the latte is linked to the u. Okay, it's linked to the choice of u. Is that okay? Very important. So what then becomes, so solution? So I will say that let u to be equal to what? So according to the latte, which one comes first? Remember the L is a logarithmic function. Okay. And since L is a logarithmic function which has a higher order as compared to other orders, okay? Or other expressions, what happened is that we were going to, make u to be what? Ln x. Is that okay? So our u is just going to be ln x. So whatsoever is left then becomes our dv. So it means that our dv would then be equal to dx. Is that okay? It's just going to be dx. Is that okay? I believe we are okay. Remember, I said that the u depends on the latte. So in this particular, terms, we have to sort out for u and our dv. Remember, but our u, for us to make a choice for u, we have to rely on the latte. And the latte, remember, the first letter here, which is L, is a logarithmic function, which has a higher order as compared to other um terms as well. Is that okay? This L has a higher order as compared to the other terms. Okay, good. So what happened is that our u will be this. And remember, we said that u has to be differentiable and the dv has to be integrable, if you could remember. So it means that my du would then be, when we take the differential of ln x, what do we get? We said that we differentiate the input and divide it by the input. So in that note, we're going to have the input. So when we differentiate the input, which is x, we get 1 divided by the input, which is x, okay? Then dx, okay? Very good. And then so what happens that we also have to take the integral of both sides. Oh, okay. What's the integral of 1? And that gives us what? Our v. The integral of 1 also gives us what? Our x. Now, according to our formula, now you remember we already deduced our formula. This is our formula, right? So our formula is what? Our formula, according to our formula, we have our formula is what? Is u dv to be equal to uv minus v du. Is that okay? Now, what is our u? Our u is ln x, okay? And our v is what? X minus, what is our v? Our v is x, and our du is what? Our u is 1 over x dx. So over here, we can see that we can do some cancellation. So we only have what? We only have this. Is that okay? So we have x multiplying ln x minus, what is the integral of 1? The integrand over here is 1, and that gives us what? X plus some constant or c. Is that okay? Okay, so remember, this is just an indefinite integral, so we add a constant c. Is that okay? Very, very important. And I believe at this point we are kind of getting we're getting there, right? Good. The understanding is coming slowly. All right, so let's take one more example to see how best we can leverage the LIATE to solve some other complex problems as well. So let's say example 2. So example 2, we want to evaluate. So we want to evaluate the integral of x multiplying e to the power 3x. Okay. Very good. So how do we sort of how do we solve this problem? How do we solve this problem? So if I were you, I would just write down my LIATE. Okay. So my LIATE. So according to my LIATE, which of these two terms becomes my, which of this, okay, becomes my u. So what is my u? So I'll just select u to be. So what will be my u according to the LIATE? So the first one is logarithmic functions. We don't have logarithmic functions here. The I is inverse trig functions. We don't have inverse trig functions. The next one is what? The arithmetic, expressions. We have that, which are full of polynomials, right? And over here, we only have a polynomial, which is x. So it means that my u is just going to be what? Is just going to be x. And then the rest becomes my dv. So my dv would just be left, would be what? Be e to the power 3x or dx. Is that okay? And I remember we said that our u has to be differentiable and our dv has to be what? Integrable, right? Very good. So let's do that. So we have our du to be equal to what? When we differentiate x, we get 1. Then we multiply by dx. Is that okay? Then over here, what do we do is that we take the integral of this. Remember, we said that dv has to be integrable. So we take the integral of that. Okay. And the integral of 1, we get v. Okay. The integral of the exponential function, what happened that we maintain that and divide it by the coefficient of x, and that is what? 3. Okay. And by using our formula, remember our formula is what? The integral of u dv equal to uv minus v du. Okay. And by doing that, what is our u? Our u is x, and our v is what? Is e to the power 3x on 3 minus, what is our v? Our v is our v is e to the power 3x on 3, and then our du is what? Dx. Now, what I will do is that I can pull out my 3 out, then I integrate e to the power 3x. When you integrate e to the power 3x, what do we get? We get e to the power 3x divided by the coefficient of x. That since it's an indefinite integral problem, we add a constant c. We add an arbitrary constant c. Okay, good. So we have our solution to be this. Is that okay? I believe everybody's okay. Good. All right. So at this point, if you have not subscribed, please do so. Like my content, comment, And let's help share this content to our colleagues, to our loved ones. So let's help demystify the myth around mathematics. All right, so let's get going. Let's solve another sort of interesting problem. So suppose I give you this problem to try on your own. Example 3. Suppose I ask you to evaluate the integral of x multiplying ln x. Okay? If I ask you to solve this problem, well then what do we do? So if I were you, as I keep mentioning, you just have to write down our latte. Okay? Now the questions, what would be our choice of u? According to latte. Latte, the L stand for logarithmic functions. And we have the logarithmic function here. Yes, so we have that. So it means that my choice of u will be straight away. So my u will be what? The ln x, okay? And then my dv will just be what? X dx, okay? Good. And remember that our u has to be differentiable and our dv has to be what? Easily what? Integrable, right? Very good. So let's do that. So it means that my du will just be what? 1 over x what? Dx. Is that okay? And then when I take the integral of on both sides, I'll get what? V equal to what? X to the power 2 on 2. Is that okay? Now, what happened is that, remember, based on our formula, we have our u dv to be equal to uv minus v du. Is that okay? Now, what is our u? Our u is ln x, and our v is what? X squared on 2. Is that okay? Then minus, what is our v? Our v is x on 2, x squared on 2, but I can pull out the half outside, okay? And then my du is what? My du is 1 on x dx. Is that okay? So over here we can do some cancellation. So this cancels that. So we're going to have, let's kind of take our time to simplify it. Now what happened is that we're going to have what? X to the power 2 on 2 ln x. Then when we integrate this, we're going to have what? X squared on 2 plus some arbitrary, constant c. And when we further sort of, simplify this a bit, you should be able to have x squared on 4 plus what? Plus c. I hope we are okay. All right. Okay, let's look at one more example so that we'll be able to have a full understanding of whatsoever we are doing now. So let's look at example 4. With example 4, suppose that we have been asked to evaluate. So suppose we want to evaluate this problem. Suppose we want to do this. So according to latte, so what do we write the latte down? Okay. So over here we see that we don't have the L, we don't have the L here. The L is logarithmic function. We don't have it. We don't have the inverse trig functions, but we have the arithmetic, which is a polynomial, right? So in that case, our u, in which case our u will be what? X to the power 2. And then our dv will be what? E to the power minus x dx. Now u has to be differentiable and dv has to be integrable. Okay. Now our it means that our du will be what? 2x dx. And then the integral of this will be what? Will be v equal to a to the, will be minus a to the power minus x, right? Now, according to our formula, we have our formula is u the integral of u dv to be equal to uv minus the integral of the v du, right? Good. Now, what is our u? Our u is what? Our u is x to the power 2, and then our v is minus e to the power minus x minus, and our v is that, so minus become plus e to the power minus x, and then our du is what? Our du is 2x dx, right? So let's try and you know simplify this a bit. So we have, all right, so it's almost as if with this particular, over here, the integral is not quite, straightforward. So we still have to reapply integration by part. Okay. We have to reapply the integration by part. And so sometimes these are some of the problems that sometimes we may face. Okay. You know, some questions may not be quite straightforward. So you may have to reapply in the integration by part, do that again, or sometimes even do it third time. Okay. And I mean, it's part of the game. It's just to, I mean, the whole point is to see whether you really understood the concept or the foundation. Okay, and as I keep saying, the foundation is so important. So once you understand the foundation, everything will be okay. You don't have to, worry or so. Okay, very important. Now, so at this point, what we will do is that we have to reapply the integration by part on this side again. So it means that my u will be what? Will be x, and my dv will be e to the power of minus that, right? So my du will be dx, and then my v will be what? Minus e to the power of x. Is that okay? So I need to reapply my integration by part again. Okay. Now, what happened is that, so we have to still use integration by part again, okay, on this part. So what I will do is that I will just have to repeat what order we've done so far, or what I will do is that I can call this my equation 1, okay? I can call this as equation 1, then I will rely on that again. So I'm trying to reestablish something here. So according to that, our formula is what? uv minus what? V du, right? What is u? My u is what? My u is x. My v is minus e to the power minus x minus, and what is my v? My v is minus that, so that becomes positive, right? And then my du is what? Dx. Is that okay? So on that note, I'm going to have something, and then the integral of this is what? Is that okay? So it means that I will just plug this. So so I would say substitute 2 into what? Into 1. And by substitution, we're going to have minus x to the power 2, e to the power minus x plus 2. Remember, the whole of this integral is what sort of yielded this. Okay, so I'm just replacing that. So minus x e to the power minus x minus e to the power minus x. Is that okay? Then plus a constant c. Remember, because this sort of but we can treat it that way, then later you will understand what we are trying to do. So we have this, okay? Then what we are going to do is that we are going to evaluate this. We don't have to add a c because we are dealing with a definite integral, okay? Then what then happen is that at the end of the day, what they're going, well, now let's simplify this a bit. Then we evaluate it at the endpoints. Okay, let's try and simplify this a bit. Let's see whether we can simplify this. So at this point, what we'll do is that we are just going to, we are just going to evaluate it, this expression at the endpoint. And the endpoint was, 0 to 7. Is that okay? We are just going to evaluate this at the endpoint. Please, do we all understand this? Are we okay with this one? Or what we can do is that we can just, factor out before, this can also be simplified a bit, okay? So what we can do is that we can kind of factor out minus e to the power minus x outside. Then when that happens, we're going to have x to the power 2 plus 2x and then plus 2, okay? Then we evaluate this at the endpoint, which is 0 to 7, okay? Very, very important. So let's kind of take time to really understand this. And at this point, if you have not subscribed, please do so. Like my content, let's help, share this powerful content to our colleagues, to our loved ones, and let's help, as well, demystify the myth around, mathematics. All right. So now what happened is that we kind of plug in the upper limit and then subtract from the lower limit. Okay. So by wherever we see x, we'll just replace by the upper limit. The upper limit is 7. Okay. So we're gonna have minus e to the power minus 7 and then 7 squared plus 2 multiplying 7 plus 2, then minus wherever I see x in the other side, we just replace it by 0. So we have 0 squared plus 2 times 0 plus 2. And when we perform our arithmetic, we should have something like minus let me say 65 e to the power minus 7 plus 2. Okay. Which is equivalent to, when you use a calculator, you should get it's approximately 1.94. Okay, very, very, very important. So let's take note. If you have any questions, please let me also know as well. If you have any questions. All right, so let's get the last example of the night. So our last example is that we're gonna, evaluate. So we want to evaluate e to the power 4x. All right, so how do we evaluate this? So we have the integral of e to the power 4x multiplying the sine of 2x. Okay? How do we evaluate this? Now, as usual, we want to kind of use the LIATE, okay? So if we are using the LIATE, remember that LIATE helps us to get a choice for u, okay? That's the essence of the LIATE. It helps us to get a choice for u. So by LIATE, they means that our u will be what? So remember, the L is stand for the logarithmic functions, the I is for the inverse, trig functions, the A is for the arithmetic functions, and we don't have any arithmetic expressions of functions. We have to kind of move on. And then the T is for the trig functions. And then we see that the sign is a trig function. So it means that our U will be the sign. Is that okay? Very good. So it means that our U will just be sine of 2x. Okay? All right. So we have, and then our dv will just be e to the power minus 4x dx. Okay. All right. So remember we said that u has to be differentiable and dv has to be integrable. Okay. So u being differentiable means that du will just be what? Minus cosine of the angle divided by the angle. Okay. Dx. And then when we take the integral on that, that gives us v to be equal to a to the power 4x divided by the coefficient of x, which is minus 4. Okay. All right. So it means that our u dv will just be equal to, now what is our u? Our u is sine of 2x. And then our v is what? A to the power minus 4x, all of that divided by minus 4, right? And then our v is e to the power minus 4x, all divided by 4x. So when we can pull that out, and that means that we can have 1 out of 4 outside, and we have e to the power minus 4x. Now, what is our du? Our du is what? Our du is minus cosine 2x on 2 dx, right? So we can further simplify it before we intend to find the integral. Okay. So when we pull out minus half outside, you're going to have 1 out of 8, the integral of minus 4x cosine of 2x dx. Now we've got to another interesting section that we have to, sit back to just reflect. Remember that in our previous problem, we encountered a situation where we have to reintegrate, okay? We have to reapply the integration by parts, and it's the case for this one, So we will have to still do so, okay? But you see that it's almost as if we've encountered the inverse or just the exact opposite of what the main problem, right? With this one, it's almost as if we've encountered, let me write it down. We've encountered the exact opposite of the main problem. So it means that, so let me write that the main problem. So we have e to the power minus 4x sine of 2x dx, okay? It's almost as if when we kind of redo that again, apply the integration by part on this side, what will happen is that we're going to arrive at that. Then we can just sort of separate them. Then we kind of get a problem solved. Okay. So, all right. So what we're going to do is that. So let's call this one equation 1. Okay. Now let's by reapplying equation by part, we'll still follow the same procedure. So let u to be what? To be the cosine of 2x, okay? And then our dv to be equal to this, right? Now our du should be equal to what? Should be sine of 2x divided by the angle, divided by the coefficient of the angle, which is 2, okay? But divided by the coefficient of x, which is 2. Good. All right, now we take the integral on both sides. You should have let me use a different. When you take the integral of this, we should have minus e to the power minus 4x on 4, okay? So what that we need to do is that, so we still have to apply the same formula, which is this. So let's do that. So what is our u? Our u is the cosine of the angle. Our u is cosine of the angle 2x. And then our v is minus e to the power 4x on 4, then minus, then the integral. What is our v? Our v is what? is minus that, but then we can pull it outside, right? So we have v is minus e to the power 4x to the power minus 4x on 4. And then our du was what? Sine of 2x on 2 dx. So dx has to be here. Good. Now, when we kind of simplify this a bit, we should have minus cosine. So we should have minus cosine of of 2x multiplying this expression. Then with this, we can also do the same. We can pull out 1 out of 8, okay? So now what happened? Now let's call this one the equation 2. So what is going to happen is that we are going to plug equation 2 into equation 1, okay? So, okay. So we're going to plug that into that, okay? So plug 2 into 1. And by doing so, remember that our equation 1 was this. So what I will do is I can just do it straight. So I'll just write down the equation 1. Equation 1, we had the integral of minus 4x sine 2x dx to be equal to, now let me look at it and rewrite that. So we have minus sine 2x e to the power minus 4x or minus, okay, on 4. Then the minus 1 over 8 outside. Then all of that will be replaced by this result. So we are going to so what is happening is that we are replacing the whole of this. What is happening? We are replacing the whole of this result by this, okay? By this particular expression that we had here. By this particular expression that we had here, okay? So we are just plugging that into that, okay? And that's what we are doing here. So take note of that. So we are having minus 4x on 4 plus 1 over 8. Then the integral of e to the power minus 4x sine multiplying sine 2x, okay? dx, good. Now, what is happening is that we have this particular, we have an expression that are the same. So we have this was the main problem. Then when we kind of went further to kind of reapply the integration by part, we kind of encounter the same thing here. So what we can do is that we can arrange them or isolate them, okay? So we have to kind of do that. We have to isolate that. So by isolating that, so we want to further simplify before we isolate. So let's do that. Let's simplify before we isolate them. So let's simplify them. So it means that we're going to have cosine of 2x multiplying minus e to the power minus 4x on what? On 32. 8 times 8, that is what? 64. So we have minus 1 out of 64. Okay. The integral of e to the power minus 4x sine 2x dx. So what then happens is that we're going to isolate the integrals. Okay, by isolating them, we are having the integral of right. So by isolating them, we're going to have now what I'm having, I'm sending this over there. Okay, so I'm by doing that, I need to add that on both sides to be equal to the cosine of that. I need to add a constant c on each side because this was an indefinite problem. Okay. Now what then happened is that over here you see that we can just factor out the integral of e to the power minus x minus 4x multiplying sine of 2x. Okay, so we can just factor that one outside, and by factoring that outside, you're going to have 1 plus what? 1 out of 64. Is that okay? I'm trying to take my time to kind of explain this because sometimes some of these can be a bit challenging. So I'm trying to take my time to really, break it down so that you understand it better. I believe we all know why I'm doing this. I'm trying to make sure that everything is well explained, well simplified, so that once I start something, I mean, nobody would be asking a lot of questions. All right. So it means that you see, when we simplify this one, we are going to have what? So 64 times 1, which is 64 plus that, which is 65 out of that. So we're going to have 65, 65. So we're going to have 65 out of 64. Okay. Then we're going to reverse this so that it can cancel that. So when we simplify this alone, we're going to have 65 out of 64. So this one will give us that. Okay. And since I want this to be isolated, the main problem to be isolated, I'm going to, take the inverse of that and multiply it by the right-hand side. So I'm going to multiply that by the 64 on 65, okay? All multiplying by minus sine of 2x, all on 4 multiplying minus 4x, then plus a constant c. So now we've been able to, finally, solve the problem. But then let's do a quick recap. Let's go over it again to make sure that everything is well solved. So we're given this problem to solve, and since we want to make a choice for you, we have to rely on the heuristic, and the heuristic is what we call the LIATE. Okay, so we saw that the u has to be the trig function of which we did so what, and we said that u has to be differentiable, and that's what we did, and we also said that the v has to be what, integrable, and that's what we also did, and that with that we have to kind of you know use our formula, and now by formula we just have to do some plugins and all of that, and that's what we had. But then when we go here, we saw that this problem, okay, we saw that we kind of saw that this one we still have to reapply the integration by parts. So we went further to still use the same procedure, and then we kind of got here. But when we go here, we saw that the main problem we are solving is exactly what we have identified here. So why don't we sort of regroup them and then try to see what we can do next? And that was exactly what we saw. What happened? We plugged these two. So we named this expression, this result as 2. Then we plug it into the 1 over here. Okay. And that brought us into this section. And with this section, what I would do was to just doing some replacement or what a substitution. And by further, simplifying, we had this result, and we kind of group them, further did some manipulations, and finally we arrived over here. So that's how come we're able to sort of solve the problem. And I want to kind of, point out that integration by part always all the time leverages the product rule and differentiation. And at this point, if you have not subscribed, please do so. Like our content, comment, help spread this content, and so that we can, create a community where there will not be math phobias. Okay, so thank you so much for your time. Thank you so much for also helping and supporting this particular platform. We are so much grateful. Thank you. Bye bye.